Ever wonder how an AI could recognize a Rhinoceros Auklet in a photo, even if it's never seen one before? That's the power of zero-shot learning, a breakthrough in AI that lets models identify objects they've never encountered. But here's the catch. Traditional systems struggle because they rely on man-made rules to connect visual patterns to abstract concepts. Think of it like trying to guess a recipe from a single ingredient. It's tricky. So how do you teach an AI to think like a human? The answer lies in semantic prototypes, the AI's best guess of what a category should look like. But here's the problem. These prototypes are often noisy. A bird's bill color might be mislabeled, or a tail shape could be obscured. It's like a teacher giving students faulty definitions. The AI gets confused and can't learn properly. That's where CLZSL steps in, a smart new framework that fixes this mess. It's got two parts, Prototype Guided Curriculum Learning, PCL, and Prototype Update, PUP. Let's break them down. First, PCL is like a teacher who starts with the easiest lessons. Imagine teaching a kid to read. You don't throw a Shakespeare play at them first. PCL does the same for AI. It prioritizes examples that match the semantic prototypes, like a bird with a clear yellow bill, before tackling trickier ones. This reduces confusion from blurry or misleading data, helping the AI build a clearer mental map. Then there's PUP, the AI's edit button. Instead of sticking to static rules, PUP updates the prototypes as the model learns. It's like revising a textbook after discovering new evidence. If the AI notices that tail shape is often mislabeled, it adjusts the prototype to match the real patterns in the data. This keeps the AI's understanding sharp and up-to-date. The results? CLZSL crushed the competition on 3 big datasets, AWA2 animals, sun, scenes, and cub birds. Especially in generalized zero-shot learning, where the AI has to handle both seen and unseen classes, it outperformed older methods. Think of it as an AI that doesn't just memorize facts but understands them, adapting as it goes. But here's where it gets even smarter. The PUP module doesn't just stick to the initial sketch. It refines the prototype over time, using visual clues from examples to dynamically adjust the class map. It's like a map that evolves as you explore new terrain. This keeps the model's understanding sharp, even for classes it's never encountered. Of course, there's still work to do. We're now exploring ways to ignore irrelevant details, like a flamingo's background noise, and make those semantic prototypes even more precise. Maybe one day, this tech could help robots recognize entirely new objects in real time, or even assist in medical diagnostics, by linking rare symptoms to unseen conditions. So what's the takeaway? Zero-shot learning is about bridging the gap between what we see and what we know. By fixing noisy prototypes and letting AI refine its own rules, CLZSL shows how machines can learn smarter, not just faster. It's a step towards systems that don't just recognize patterns, but reason about them. Next time you see an AI guess something it's never seen, remember, it's not just luck. It's a little bit of human-like thinking, powered by clever science. Stay curious, and we'll see you in the next video. Ever wonder how a computer could recognize a flamingo without being shown a single picture of one? That's the magic of zero-shot learning, training models to identify things they've never seen before. But here's the catch. When you're teaching a machine to connect visual clues, like a bird's shape or color, with abstract concepts like flamingo, mismatches happen. In our research, we tackled this problem with a fresh approach called CLZSL. Think of it like a 2-part strategy. First, we use something we call the Prototype Guided Curriculum Learning Module, or PCL. Imagine a teacher who doesn't just hand out the same old textbook to every student. Instead, they prioritize the ones who are already getting the material, those visual examples that closely match the class's semantic prototype, like a rough sketch of what a flamingo should look like. By focusing on these strong matches first, we reduce confusion and help the model learn more accurately. But here's where it gets even smarter. The second part, the Prototype Update Module, or PUP, doesn't just stick to the initial sketch. It refines the prototype over time. Picture a map that evolves as you explore new terrain. The PUP module uses the visual clues from the examples it's seen to dynamically adjust the class map, like updating that flamingo sketch with new details from similar birds. This keeps the model's understanding sharp, even for classes it's never encountered. The results? Our model created a much clearer bridge between what things look like and what they mean. It's like giving the computer a better dictionary, where each word isn't just a definition, but a vivid, evolving image. And the best part? This approach outperformed previous methods in transferring knowledge from seen to unseen classes. Thanks for watching. If you're curious about how machines learn to think like humans, hit subscribe. And let us know in the comments, what's one thing you'd love to see a zero-shot model recognize? Maybe a unicorn.